afternoon, everyone. My name is David Gessner, and I'm going to present the paper titled Towards Reliability Analysis of the Design Space for the Communication Subsystem of FT4FTT. So what is a design space? When we face a new problem that should be solved by a system, that system first needs to be designed. For such a design, there are usually many possible solutions. As a simple example, consider the problem of storing some physical items. We might solve such a problem by designing a simple box to serve as a container. In that case, one solution might be a shallow box, another one might be a tall box, and yet another solution might be a square box. Each such potential solution is specified by so-called design variables. In this simple example, the design variables might be the height of the box, its width, or its thickness. Using the concept of design variables, we can represent each potential solution as a tuple, where each element of the tuple is the value of one of the design variables. So the first element might be the value of the height, the second the width, and the last one the thickness. If we have a total of n design variables, then each tuple will have n elements. In that case, we can define an n-dimensional space where each dimension corresponds to one of the design variables. Such a space is called a design space, and each potential solution can be thought of as a point in this space. The specific design space we are tackling in the paper is the one for the communication subsystem for FT4FTT. FT4FTT is a project we are currently working on. Its goal is to provide high reliability and flexibility for distributed embedded systems. But the two important things to note for this presentation is that FT4FTT, due to the underlying technology used, requires the communication subsystem to be master-slave and to be based on switched Ethernet. This means that the points of the corresponding design space will be master-slave network architectures that use switches. A few example designs are a single switch with an external master node and two slaves, a single switch with an embedded master and two slaves, two interconnected switches with an external master and yet again two slaves, or the same with the masters embedded. Given a design space, we're often interested in which design is optimal, that is, best according to some criteria. In the context of the FT4FTT project, our criteria is reliability. So what we are asking ourselves is which design is most optimal, most reliable. So to answer this question, we propose a way of evaluating the reliability of all points of the design space in an automated way. We do this by creating a single model for the whole design space. The idea basically works as follows. Each point of the design space can be modeled as a graph. So this one can be modeled by one graph, another, and so forth. Since each point can be modeled as a graph, the set of all points can also be modeled as a graph. This single graph captures the whole design space, and it is obtained as the graph union of all the others. Then, using this design space union graph, what we do is we generate a continuous time Markov chain from it. And using this continuous time Markov chain, we then evaluate the reliability of each design of the design space. In this way, given the design space, we can say for each individual point what its reliability is. And if we know the reliability of each point, we can then clearly identify which design is most reliable. If you are interested in further details, such as how exactly we